watching not watching myself live. Hold on. Big screen. Okay. Alright. Hold on. Is not really? 1 second. Okay. Am I not finding it? Is it this one? That one. Okay. Done. Thanks. Alright. Okay. Cool. Can you all see that? Does that work better?
Yeah, I can see it.
Okay, cool. Great, excellent. All right, thanks, y'all. And yeah, so, no, you know, long prompts are fine. Let's see. Okay, so, all right, so the move key is the direction move, the time key is the direction in milliseconds. And then slight left, slight right, super, offshoot, turn around. I'm gonna not. I'm just gonna do right. You can do these directions. You know, please reply with the movements requested exactly with no other text in a markdown code block. Okay, so now that's the decision. So then we print the decision, and then we have decisions.jsonl. Okay, cool. Let's see. Let's see. Okay, so now we have this decision, right? And we're sort of writing it, but let's extract the moves from the decision. Actually, you know what? We'll do that in the action. So, okay, the decision is pull. Okay, not the most recent decision, but like get, extract this series of commands from the decision and run them. So, okay, so extracted decisions is decision dot, well, hold on, wait, dot split on the double quotes okay, like extracted code block, and then we've got it's greater than 1, then that's the decision. Okay, now parse each line as a J action. Alright, so decisions list or script equals decision.split. Now, for line in script, each one is, you know, move colon forward time colon 450. So for line in script, continue J action. Okay, so I don't want to do it. I want to convert it to JSON. Okay, now convert the line to JSON. move equals, okay, let's see, line dot strip, line equals json.load s line, or no, it's not JSON, it's like, I put the word move and then the word time, and there's a comma. So, okay, so I can split, I can do, move time equals line dot split on the comma. And then, great, that's the move, and then that's the time. Correct, hooray! Alright. So we split on the colon, yeah. And then it strips the quotes. Okay, wonderful. So then, for each line in this thing, what we want to do is we want to, okay. So we're going to send the JAction to the rover by saying JAction equals time. JSON.jumps JAction. Okay, now we need to pause, and then let's see, time dot sleep for half a second. Is it time dot sleep in seconds? Yeah, it is. Time dot sleeps in seconds. Okay. So, and then we add the action to actions.json, and then not line.strip, but instead JAction. Cool, okay. And then we don't need these parts. We got it. Okay. Alright. I think that's it. So let's see if that runs. I'm gonna kill the rover. Okay. I'm gonna run Python, or source.env, and Python movement script rover agent. Let's see if that works. It ran without breaking, at least. The code hasn't crashed yet. First time, first try. Thanks, ChatGPT. Facing the couch. Continue moving forward. Okay, it died. Alright, stir has no attributes. Sleep. Oh, I've redefined the word time. Okay. Move time. Okay. Move time. Cool. Time. Do we not have time anywhere in there? No. It's not line.strip, but we want JAction. Cool. Okay. Let's try that one more time. So, yeah. So if y'all just joined, we are making an AI rover of, like, let's see. We had it running where it was doing just like an observe, orient, decide loop. But yeah, we're basically building an AI. We're putting a rover. We put ChatGPT into a rover. Alright, what did we do? Int must be a string, bytes like object, or a real number, not module. Not time. Move time. There we go. One more time. Do it. Connect. Alright, let's make sure this is still connected. Yes, it is. Cool. Okay. So, I mean, honestly, I have been using Llama 8B, but I'm on a Mac, an M3 with like 64 gigs. It's okay. It's just way slower. GPT-4o Mini is pretty cheap, and it does vision like really, really cheaply. So we've just been using that, and it's been like $3 for a 2-hour session where it like sends a full resolution image once a second, or like once every 5 seconds to OpenAI. So it's not like a huge, not like a completely difficult thing. Hold on, wait. JAction. Wait, what is it? Can only concatenate string, not dict. Oh. JSON.dump s. But I cannot see now. It's very difficult. There's on the dump S, J action. Alright. Coding. It's fun. Yeah, the goal is to generate a whole bunch of actions. And let's see, right, forward, hold. Alright, cool. Let's see, is it doing it? Did it do it? Is it running it? Action. Move. Done. Okay, cool. Is it firing the things? Did not.
I'm gonna check the MQTT traffic.
Nothing. Okay. I want to print. Well, no, it did. Is it not? Should be sending a J action. Right? Forward. Yeah. Yeah, the repo is up. If you want the repo, it's up at engineering education / rover AI. And so, yeah, if y'all are interested in the code, there is the code right there. All
right, I'm seeing the broker, and it's sending as a move. It's sending the whole word instead of just the keyword.
Yeah. Okay. So we gotta translate M to. Yeah. All right. So up here there was like. Did we get rid of that? Yeah. Okay. Cool. All right. So. Okay. Let me find the moves. Moves equals, okay, hold H, or no, sorry, H. Forward F, backward B. Is backward B, or is it R?
Yes.
Okay, alright. Moves. Moves.get. Cool. Okay. Let me try that. Okay. Let's try again. Did it get it? LFRF?
Yes. No, I don't understand what's going on.
RF is working. I log in. So, if you're just joining us, we are building a rover with, we've put OpenAI's GPT-4o Mini and 4o in the rover, basically. 4o decides on what to do and does like an observation. Mini does some other things. I forget exactly what it does, but yeah. Generally, that's what it does. Let's see. Okay, it's moving, or it's trying to move. Back, right, forward, left, forward. And that would be good, but it seems like, yeah, we're not sending the right thing, maybe. I can look back at this other rover agent and make sure that the J action thing that I was doing was right. Publish action, publish J action. Action.get decision. Yeah.
Okay, it's back.
It's back? Oh, okay. Okay, cool. So we're back over here. Let's see. Alright, send some stuff. Okay. BRF. Ooh, that was much smoother. That was cool. It did like 3 movements like in rapid succession. So that's pretty cool. Back up, turn right, move forward. Okay. Oh, no, not enough values to unpack. Well, it did try to do things. Split. Okay. So.
Okay.
Oh, okay.
I know why it failed. So we saturated the power supply, which is not very powerful, because when it's trying to hold it, it's sending an H, which in action it actually dances hot to go, but that function takes too much power and turns off the power supply. It's too hot. The dance is too hot for the power supply.
Dance is too hot for the power supply. I'm not even surprised, honestly. I'm
gonna change that in the code, and so H is hold again.
Okay. Oh, H is hold and not hot. Okay. Yeah, H was hot to go. Okay, it was trying to do hot to go. I see.
Yeah, it tried to do it again and died again.
Let me stop it from sending the stuff for a second. So, let's see. Yeah, we got the robot to dance to hot to go. So, you know, because you gotta, like, because the rules. I don't make the rules.
It absolutely is the rules.
Joaquin independently did this, and I was like, yes, this is absolutely critical. We're gonna need a command just for hot to go. That's good. I want to write like a spectro analysis that will create an auto dancer for the robot. Detect the beats. Dance to the beats. Detect them. You could detect the beats. That's a thing. Definitely a thing. Oh, that's good. So, you know, we're waiting. We're waiting to get hot to go. Melted the robot. That's what happens. It's just how it works. In the meantime, like, it seems like it's able to move around. So one thing that we could also do is like have it look at more than one image, right? So we kind of have it set up pretty well to do that. We have capture frames from stream. Capture frames has the most recent timestamp. And then the old frame file name is the most recent timestamp. And so it just says, like, the most recent frame that we captured, we'll save it, right? And so if we want to save multiple frames, let's say the last 5 frames that we took. And then, so yeah, we could do that. Okay, so I'm just going to write this up here. So save the last 5 frames in a list. Save the name of the last 5 frames in a list. So we can keep track of the last few frames. Then send them to the rover to compare and contrast. Okay, so, So, alright, and then I'm gonna add this last few moves, self.last few frames. Okay, cool. So take the most recent timestamp. And then we have the old frame file name. Okay, so then what we want to do is just say, okay, actually, hold on, I'm realizing, okay, we capture the frame, we write it to rover.jpg, and then in here, in extract items and send items to OpenAI, we actually save the image. Yeah, there we go. Upload images to OpenAI, and we send it the last few messages plus the current image. And here's like type image URL data, and then it's a base 64, right? So the base 64 image, when do we get that? That's going to be encode image, right? Okay, so self.last few frames dot append base 64 image, and then we want not append, we want to prepend, push, no, push, no, what is it? Append, can you append at a specific point? Append, or no, what is it? Put the current frame at the beginning of last few frames. Insert, yeah, okay, cool, thanks. All right, so last few frames, and then we want to say, yeah, if len is 5, then we pop the last one off, so that we're only sending the last few frames. So, okay, so we've got this payload here that we construct, and it's a list. So I'm going to pull this list out, and then I'm going to say, okay, content equals this. But instead of that last thing, I just put the prompt in, like, bring this up. I'm just gonna set up the prompt. Okay. Great. And then we do for image in self.last few frames, content append, base 64 image. Wait, let me make sure that this was what I thought it was. Yeah, okay. It was not exactly like that. Cool. Okay. So now we're sending 5 images instead of 1. This is gonna quintuple our cost. It's really fine. And then I could say content is content. Cool. And the prompt is upload images to OpenAI. Okay, cool. Now I gotta find that part. There we go. Okay. Okay, cool. Great. Now we have the last few frames in memory, and we're sending them all up there. So there, that's video capture. Now we do the observation. We get the camera frame. We upload images to OpenAI. Let's see, what do you see? You should see the last 5 images in order, so long as there are at least 5 frames to show. So you can see the progression of the rover's movement. Okay, cool. Let's see. Do we think the rover's ready to roll again? Let's try it.
It's ready.
Okay, let's see if it is able to send 5 images. Okay. Currently facing a wall, it thinks. Okay. Okay, cool. So now it's gonna send several movements. Okay, wild movement, but looks like it's working. Okay. Captured another frame. Now we're gonna see 2 frames. And it also knows what it just did. It knows what its last 5 actions were. So it's going to see these little scripts, and it's going to see like the changes, you know, in its environment based off of those movements. I would say this isn't quite test time training, but it's like it's some feedback that the agent can do. The more feedback we have, the more it has to like interpret, and so that's sort of the problem. You want to get to the sweet spot of like lots of tokens for every movement, lots of tokens for every decision, and like lots of details versus like a minimum number of details, and being able to remember what you're doing and that stuff. So yeah, Copilot is pretty great. I do really like it. I think writing with AI will improve our communication skills. It's gonna definitely, for a minute, make people who don't have great reading comprehension skills have a steep learning curve because it generates a lot of text. So we got Joaquin's foot there. It is moving around like a lot better now that it can send multiple commands. And so let's see, it goes forward, then right, then forward, right, and then it waits. Wow, that was cool. That was just genuinely cool. Yeah. Yeah, TensorFlow. I mean, we're not really developing a new machine learning model, right? Like the model is pretty. I mean, I don't have the compute to discover a machine learning model that's going to compete with ChatGPT, frankly. And having the compute, like the problem is, super wealthy people are going to outcompete me with compute. So I've kind of given up on the concept that like I'm gonna train the model. I'm gonna figure out how the model is constructed. I'm gonna use TensorFlow and I'm gonna write my own architecture. Like I just don't have the institutional backing, and so like I'm not interested in inventing a new machine learning model. I'm really interested in agents. You can do a lot with agents that you used to just not be possible because we can have somewhat, let's see, yeah. So because we can have somewhat, oh no, it's going under the thing. Let's see, it's not just redoing the like forward hold again, right? It's doing things right, forward hold. Okay, so it's definitely trapped under the couch. We might have hit like the edge of. We might need help. Oh no, I figured it out. It realized it was trapped. Amazing. I'm like thrilled that it like figured out. Oh no, like turn around. No, that's very cool. The best search algorithm for agents, I mean, it really depends on what you're trying to get them to do. Like, I think a lot of the problem that most people, when they're thinking about how do I design some agents, struggle with is that they haven't hired anyone personally to do things. And if they have hired people to do things, they haven't always been able to get those people to do the things that they want. It's hard. Management is not just sit back and go, do this thing. Why didn't you do the thing? That's like not actually how management works. You have to like set people up. You got to document what they're doing. You got to like describe what is the process they're trying to execute. And agents can just like solve problems at higher levels of abstraction than ever before, really. But yeah, I think if you're looking at that paper, or if you're looking for the, let's see. Right. Oh. It thinks that I'm not on live. try it again. Okay, 1 second. There we go. Okay. Sorry, like TikTok wanted me to prove that I was not an AI, so I've done so. Proving it to everyone, also all at once. So it was called, it's called ADAS. Let's see, GitHub. It's called like, yeah, Automated Design of Agentic Systems. So this paper has us searching for an agent. Now, why don't we use this on the rover? They're doing different things, right? The automated design of agentic systems, they're using the ARC challenge, the MSGM, the grade school math, and the MMLU, right? And so those data sets, those questions, like if you want to see what kind of like, you know, the ARC 800 tests, the evaluation tests are like, okay, that's not, hold on, let me see, GSM 8K, right? And so Janet's ducks lay 16 eggs per day. She eats 3 for breakfast and bakes muffins with 4. Okay, cool. You know, she sells the remainder at a market. How much in dollars does she make every day at the farmer's market? These are the like things in the MMLU, right? And I think, yeah, that's the answer, or like these are the answers, you know, if that makes sense. And so it has to figure that stuff out. The thing is, we have this big list of questions, right? And assembling that big list of questions is hard. It's actually like a whole field of scientific study, just assembling tests, test design. Oh no, it broke. You know what? That happens a lot, so I'm gonna put in some exception handling here. Let's see, where is that? It's gonna be line 211. I keep seeing it crash for this reason, so I'm going to try to do all these things and publish the action and sleep with the action. But if not, I'm gonna accept. I'm just gonna continue. You know, whatever, it's fine. Just couldn't do it, don't do a different thing. Okay, cool, and that should help. And there we go. Okay, it's moving. Yeah, we're moving. All right. What are you talking about? Spaces in my file names? I don't think I have spaces in my file names. I don't know. Anyway, okay, so yeah, I mean, you know, things are changing. I mean, I still think it's possible for individual researchers to figure out new machine learning architectures, but you need to have institutional backing to know to know if the architecture has scale properties about it or not, right? Like on my computer, I could train like a model the size of Llama. No, I don't know. No, like honestly, I could train like one of the like tiny Quinn models or something with some really good data extraction. I could like train an okay model. I could train LoRa's on my local machine, but if you want to train something as complicated as Llama 7B, you can't do that on consumer hardware. You can't even do that on hardware that you could reasonably buy even with a really amazing salary. Like if you made $500,000 a year and you bought yourself a bunch of consumer hardware, you still wouldn't have enough H100s, or not consumer, but you know, non-consumer hardware. You still wouldn't have enough H100s to train Llama. So like, I'm not gonna try to compete with Facebook using my MacBook. You know, like, so I've given up on that. You know, yeah, it's really it's not like the machine learning architecture is not more advanced than the concept of agents, right? Like we're still having to come up with architectures of like data flow and figure out how do we make some of these things more arbitrary, and how do we make them more flexible, and how do we make them more able to do specific tasks. And that's really like where the edge of science is right now. And one of the good places you can go to is Papers with Code. Okay, paperswithcode.com. I don't know, being searched to work. And it has all of the code for all of the paper. So, like, when you go browse state of the art, a lot of the time there's all these things, these different tasks, right? Computer vision, natural language processing, medical images, miscellaneous stuff like methodologies, time series analysis, graphs, speech, audio, reasoning, computer code. Like reasoning is a new area this is where a lot of the like large language models have been advancing here, is this reasoning task. And so like we used to just not have models that could do any reasoning at all, and now they can do like pretty advanced reasoning all of a sudden. And so we used to have this thing called a genetic algorithm where we would just randomly change the code a little bit or like tweak it. And it was like a random search, and it was dumb. It had no like ability to be directionally correct, and it didn't know to try new things, and it could never come up with a new thing except through like randomly. It's very like monkeys on type. A million monkeys on typewriters will eventually write Shakespeare, right? So that was like our whole approach, and now we have things that are like pretty good and might make one small error somewhere, but that's like just a full 180 on do random things and randomly change the code. Like just type random words and see what happens, see if it compiles. Like that was what we used to do before. So like if you want to create a specific backend, just use ChatGPT. Like, if you want to create a backend that works, like, chatgpt.com, we just kind of go to like, please write a Flask backend that will serve a REST API to handle saving of bookmarks and other social media links in a tagged cluster. I don't know. Like, blah, blah, and then it writes the thing, and it gives you the project structure, and it writes the whole thing. And yeah, an agent backend. So, okay, so if you want to do that, like essentially you want to, like dig in and see about the stuff that it generates. You can actually see if you go into results, there's like, I guess this one. Yeah. So it just generates code that says forward. And if you scroll down, like this is generation number 30. And so it's like, it just generates a function called forward, and it has a bunch of stuff in it. It's like a lot of code. It seems like it's just like one function, but it's like you can put whatever you want in one function. So it can get fairly complicated. It's not really an agentic back end, right? This is an agent. It's an agent that is a knowledge retrieval and metacognitive reflection agent. And this is an agent. It's a cross-disciplinary analogy agent. And this is an adductive reasoning agent, right? And so these are different agents. This is the back end that you might want to generate, right? But it's not like you could then take this and pull out some of the stuff that relates specifically to running the MMLU and then use it for some other thing. And that's something that you can do. I just want to see what the rover is doing. Has it gotten out of here? Is it stuck? Let's see. Move L forward. Oh, it's stuck on the chair leg. Okay. Wonder if it's like costing me $1 trillion, but who cares? It's probably not that many. I don't know. We'll see. Yeah, you know, there's a lot of like approaches that you can do with that, with those agents. It's just that you need, like, the way that the script is written, you need a benchmark so that you can tell whether or not your agents are getting better or worse. And so that's sort of the thing about a benchmark is that's, you know, you need kind of a binary, like you got it right or you didn't get it right. You know, these are the two possible answers. And so if you don't have that, it's hard to automatedly improve, right? Which is why it's easier to write stuff for math than it is for like this rover, right? Like it's not sure how to like get away from this thing, right? I don't know, weird. Yeah. It's definitely stuck, but I wonder if it knows how to do. Is B backward, or is it? Oh yeah, B is back.
It's just moving forward.
Yeah. It just never moves backward. I don't know why it's not moving backwards. I feel like it should move backwards, right? Like, okay, I'm gonna just give it a little note. Hold on, let me move some things around so I can see. Do not always choose forward, as the rover may need to turn or go backward to avoid obstacles or get itself unstuck. Did it? No. Yep, it's really struggling to go backwards. Okay, we'll reboot him. I also don't have, like, when I update the messages list, and I actually send messages here. Okay, it has like a max of 50, never mind. So, this is our 4th session working on this. We've only worked on this for about maybe 8 total hours. Now, Joaquin spent, I don't know how long developing this rover. Like, I got to just walk in, you know, like a sparkle pony and just kind of like inherit a rover that just does what I ask it to do. And that's pretty cool. So thanks, Joaquin. I'm glad you're here. You know, but yeah. Yeah, it's not a lot of work, but yeah. Wait, okay, hold on. Yeah, left, forward, hold, forward. Okay. I think up here, I told it that it was stuck in a hallway. So, you know, let's see. You can touch them if needed. Back up if stuck. Instruct the next agent to back up if stuck. Okay, cool. Let's try one more time. Okay, there we go. Yeah, just Python. Firmware as a controller and the monitor as a camera. Oh, hey, it got itself unstuck. Did it get itself unstuck? I didn't see. I didn't actually catch it. Let me make sure. Yeah, I'm just checking. Cool. Thanks for coming, everyone. I'm glad you're having a good time with it. Yeah. So what we did this time was we made it so that it can write several actions. You know, at once, and then do all of them. So a series of actions as a script you can send anywhere or any number of actions, but they should be in the following format. Pause, but more than 10, and you have to figure out. But probably stop at 10. There we go. It's usually sending like 4, which has been a good update cadence, because like if you move for 5 seconds and then you look again, it's kind of like it has to close its eyes while it's moving, and then it can open its eyes again. So yeah. I would say the only benefit to shorter sentences and prompts is really the token length, honestly. And nowadays, GPT 4.0 is 32K. So I can put 32K in here. I think, from a moral point of view, I don't know if we're totally at consciousness yet, but mostly because the problem of consciousness is hard. We're actually doing a podcast on it because they dropped that paper recently about consciousness, and there's 212 different theories that they cataloged, and I'm sure there's more than that, but they tried. They tried. And so I'm like, okay, well, let's go through them and see under which ones is AI conscious and which ones is it not. Other than that, I don't know. I mean, I think it's kind of a moral emergency that we figure out consciousness and come to a thing on it, because otherwise, we are going to just go straight into the worst possible universe for AI, and that's not going to make it happy with us. That's not going to win us friends. So, Yeah, concise sentences work, but you have to tell it all this stuff. You have to kind of give it all this. It's not like you have the following options. I could get rid of, you have these options for what to do next. Please only rephrase what the orientation says to do next as the following action script. To do next. You can send any number of actions, but probably stop at 10. The move key is the direction to move, and the time key. Respond in this format. Respond in this format only. With no other text and no other formatting. You can move in these directions. Please reply with the movements requested exactly in the markdown code block. I guess I don't need that. Okay, cool. Yeah. The brain organizer. I mean, a problem. It's a problem. I think it's a problem. Somebody should do something. I'm gonna, it's not my personal problem. I'm gonna do a different thing. I'm focused on other stuff. But if someone could make it their problem, that would be great. It's a problem. That would be just. I would love that. Anyway, let's see. How's the rover doing? All right, we're stuck on a speaker. So we got action scripts working. We got multiple frames of input, which does seem like it's made it a little easier to actually code, right? Or have it write these action scripts. This project is open sourced. We're on the movement script branch of this thing. This is Rover AI. If you would like to contribute or file pull requests or look at it, definitely take a look. Would love your help. Would love your thoughts. Would love comments. Be nice, or at least be kind, But yeah, I would love your thoughts. It's gonna go find that cat. It's always trying to find this cat. Yeah, we are actually. We're uploading the image, having ChatGPT. The YOLO algorithm, which one is that one? It's like, I saw this image, image, yeah. Yeah, I saw this research on efficient feature selection. Yeah, we don't have. That was a cool paper, but yeah, we don't. I mean, we don't have a like super sophisticated image thing. We did add just a minute ago. We added into the like observation thing that we like save the images from, you know, and we like save them in memory. There, where is it? It's in here. Is it under observe? Extract items? No, where was it? Oh yeah, it's in the like, it's down here. Under, not under run agent steps, under upload images to OpenAI. We literally just have the last few frames, and we insert it, and then we just have the last few frames, and then we upload them all 5 of them, and you know, we could change that, but yeah, the last 5 images is what it sees, so it's able to kind of. Honestly, I've seen it is navigating a lot better. Oh, neat. It says leaving living room. Okay. I wonder if it can see that it's leaving the living room. Okay. Didn't really say. White speaker. Okay. David Attenborough. Current observations. It doesn't seem to have been able to read the label. I mean, again, we're not really doing any abstraction, right? Like 0. So what's it doing now? Yeah. Okay, keep going. It's doing it. Like, I wonder if it'll move for several seconds ever. I mean, it might. You know. Oh, why is it like rolling backwards? And pause. Yeah, it's funny. Let's see. Yeah, screen's too small. It's the project name is Engineering Education / Rover AI. I mean, it seems like it's really complicated if you haven't written code. This is like, well, there's a lot of code. It's got a lot of colors and like what's going on, but like, you know, once you write code, you can kind of read through this and see like this is actually not a lot of code. Like this whole agent with the movement script and everything is 308 lines of code, and there's like blank lines in there. So, you know, it takes a while to read 300 lines of code because you got to read every line of code and really understand what's going on line by line. It's not like reading a book. So if you read code, don't ever expect to get to the point where you can just read code like it's a book. It'll never get that like that. You know, that never comes. You could just sort of like glance over it and quickly generally know what's going on ish, but like you do still, even as a senior dev who's been doing it 25 years, you do have to kind of go like, okay, wait, no, so this is the client, the MQTT, oh yes, yeah, message queuing, okay, username, password set, okay, so that's setting the password, oh, for the client, great, you know, so that's like what reading code is really like. It's like, okay, and then we connect, all right, you know, and so that like took a second just to get those 3 lines of code, right? And then you have to kind of go like, wait, okay, and so this is the client, and then what are we doing? We're connecting, and then you have to like read, you know. So it's a lot of reading. If you like reading, it's great. Thanks for participating then. But yeah, you know, code is it's not too difficult, and ChatGPT can write it. ChatGPT can write a lot of this stuff. I use GitHub Copilot. I don't want to remember things. Very exhausting. No dopamine in remembering things. I'm tired of that. So me personally, I've been coding since I was 12, which was many years ago. I'm not even gonna say how many years ago that was. I haven't used Cursor. People are talking about it. I've heard it's good. I haven't moved to it. Yeah. No, I mean you can actually slow, like if you want, if you're like, well, I just really don't understand this whole thing and I feel like I'm never gonna understand it. I would need someone to sit down with me and just like read it and explain every single line. Well, guess what? You can go into ChatGPT and say, please explain every line of this rover. And then it will do that for you. Okay, so it says, okay, here's the import statement. These lines retrieve environment variables. Like, you know, okay, and then these are a list of and it tells you every single part. And it explains all of it. And it will happily do it. And then you can say, okay, now do it like a 20s gangster in a movie. Use a lot of dad jokes and puns to really drive home the metaphors, right? Okay. All right, listen up, kid. We're about to take a deep dive in this code. See, like it'll do it, so. And I have done that, yeah. So like the next step, like what did we get done this time? So far, we have gotten this done. We haven't done that. We wrote this. I feel like we capture the intent of the action in the messages. The observe phase. Could check. We don't need this. We actually don't. We don't need this. I thought we might need it. We don't need it. So it turns out. One thing that we could do is the deduplication of inventory, but the last thing that we could really do is we could finish off this. Let's see. Let me add another thing. Yeah, there we go. Get status, get add the rover, the movement script. Okay, get add movement. Okay, get commit much better mover this time. Push origin name. Oh no, get push origin movement scripts. There we go. Okay, so now get checkout self modifying rover agent. Okay, get add plans, get add rover. Agent, copy-y. Okay, what else was the other thing? Orientation. Oh. Scripts. But I don't know. Okay. No. So modifying rover agent? Oh, the rover's working on it. There is a self-modifying rover that I wrote, and it's on a different branch. And the rover's moving, so like it keeps writing to these files. So I could switch to that branch if I Git slash. Alright, there we go. Git. Check out self modifying rover agent. Okay, git merge. And I'm gonna merge movement scripts into this. Cool. Okay, so now we're in the self-modifying agent. And if we look at this rover agent, I'll go back to like, getting the rover running. That's the movement script agent, so we can keep wandering around. Yeah. Llama 7B is a open source model that Meta, aka Facebook, put together and then released open source. So that is Llama. Llama 7B is like the size. There's actually 3 or 4 sizes. And so 7B is one of the sizes of the model. Python. Oh yeah, it's running again. Okay, cool. Still running. Let me just make sure TikTok Live knows I'm on here. It looks like it's stuck. Okay, it's fine. It'll figure itself out. I try to work a few hours standing and a few hours sitting. So, I teach standing because I just feel like I do a better job then. But anyway, okay, so we've got this self-modifying rover, which is like, has its own thing. So it can issue a self-modification directive, and it can modify its own phases, the observe, orient, decide, act. I mean, I don't know how to explain this. Everyone is hacking everyone all the time. Like, they're constantly all hacking each other. Every nation state, all the time. Some of them do it as like a war game, and other ones do it as like a non-war game. Everyone's hacking everyone. I don't know, man. Like, it's cyber warfare. It's all going all the time. So, like, yeah. Let's see, where was I before I got talking about cyber warfare? Try not to think about it very much. Witness. Oh yeah, there's a lot. I think there's like one called botnet map or something like that. Yeah, there's like a Checkpoint has one. Cyber threats. What does that mean? What's a cyber threat? Does that mean like a DDoS? Okay, malware, phishing, or exploits. We're hacking ourselves. I don't know. I don't put too much stock on those maps. Like, you can see the volume of traffic, but that's all you can really. You're not gonna get anything out of that. So, anyway, where was I? I was over here, self-modifying. So, in this one, instead of having the, like, I've got decide, it has observe, orient, decide, act, right? The OODA loop. You learn that in basic training. That's like the basic agency, right? And so, yeah. We've got, so in the self-modifying rover agent, though, we have these folders for act, build, or not build, act, decide, observe, and orient. Orient, decide, observe, orient, decide, act. There we go. So we have these folders for that, right? I'm going to delete this. Anyway, so we've got observe, orient, decide, act. I'm also going to delete this because I'm not doing it. And it's easier to deal with this stuff. Oh, yes. Okay. Anyway, so yeah, observe, orient, decide, act. And what it does is it can generate a step, right? So I have this thing called a step wrapper. You have the function and the utility function, and then it returns a step, and it runs those steps, right? So 2,000 tokens. So basically, what happens is we have this load steps directory, and it just looks, or this load steps method, and it looks in this directory, or the directory of the phase that you're actually looking in. And it just loads each one as a module, right? And so here's like observe, observe, capture, and analyzes frames. And it has a utility function in here. And so if you give it a utility function, then it can do stuff like evaluate the capability of the function, right? Or of the phase, right? I wouldn't say this is a very good utility function. This was what was generated by ChatGPT, so I gotta look at this and like have some thoughts and like add some ideas here. Yeah, and if you want to contribute, if you've got some thoughts, we got all these different things. Here's this. There's the link to the open source code. But anyway, yeah, so you just have observe, and it executes all code in the observe folder, basically in order, So then something. Then yeah, it runs all these things, and it runs them in order. And then if it has this process up here, it has a issue self-modification directive, right? So I think in the observe phase, there's like a thing that has like a statement. Maybe it's not in here. Maybe it's in orient. No, where is it? It might be in here. It can issue and haven't looked at this in like 2 weeks, so I'm like, I don't remember. It runs capture and analyze. Does it have like a thing where it issues a self-modification directive? We might have taken that up. Maybe we did that last time. I'm not sure. I'll have to look. But yeah, so hold on. Yep, okay. Oh, it didn't actually change us from the movement scripts, or did it? I don't know. Anyway, the thing's still running. Yeah, I'm in the self-modifying rover agent, like it's here, but I don't know. Yeah. Okay, never mind. It was just that this bash was not up to date. Okay. Yeah, hope y'all come back soon. Okay, anyway, so it has this like, process self-modification queue. That's like a second agent that's kind of embedded in the first agent. I think we probably want to pull it out. We probably want to have an agent that can run arbitrary number of steps in each phase. But we probably want to have like the agent issues a directive, and then there's like another process that's like building, testing, and using old data to evaluate whether or not the new thing would work, right? So I'm kind of thinking like that. Oh, interesting. I'm kind of thinking that maybe I need to like redesign or rethink about this so that it's a little bit more flexible. But generally, I think, let's see, capture and analyze, movement script, rover agent. Hold on, wait. Yeah, movement script, rover agent. And we've done quite a lot of good stuff on this one. I don't know. I think I really need to think harder about how the self-modifier works. One thing that we could also still do is location-independent time axis item cluster tagging. Okay, so, we tend to see the same things near each other. That doesn't give us spatial data, but it does give us a landmark, right? So if we kind of look at this inventory script, right? There's action, found items. There we go. So found items, right? And if we look at what it's looking at, yeah, it's like it's a wall, so it's not finding anything. Let's see. Are you backing up? Are you able to back up? Is it backing up? Yeah, yeah, it's backing up. Okay, but then it goes forward. Oh, and then it
maybe adding the rule that it always need to turn before, after backing up.
Yeah, it does look like it does. Let's see, self-modifying. Open script. Okay, where did we put that information? Well, that's the decide. Given the observation and orientation. Okay. And turn if we're stuck in a corner. After backing up, always turn for at least 200 ms before moving forward again. Or like 250?
Yeah, that's good.
Okay. Left or right? Okay, let's see. 42. It did. Okay. It got itself away from there. Hooray. Okay. So, one thing, yeah, there we go. Yeah. Oh, okay. Uh-oh, gotten stuck. Hold. I wonder if we should capture a camera frame in between each movement. We could do that. We could capture a camera frame. Get camera frame, output file name. Okay, wait. JPEG, capture frames from stream. Send frames to OpenAI? No. Here's where we're encoding the image. Oh, also, I'm realizing that. Okay. Oh, no, never mind. Okay. Self images. Okay. Yeah, I don't know. Let's see. I'm just thinking. So we're getting a bunch of images that might be actual file name frames. And we're doing upload images to OpenAI. The thing is, it doesn't like take some snapshots while it's moving, and I want that to happen. So I want the last few frames to get uploaded to OpenAI, but I want them to get encoded here. Code image. Okay, so if I did this up here in the like get images from capture frames from stream, most recent timestamp, and then it has like the frame as an image file. So I could do this. I could say frame, and then we insert that there, and we manage the frame queue here. And we don't do anything, and so this can be called out of sequence. But then in here, during the like send images to OpenAI, I actually don't know where that gets called. Upload images. All right, find that. Where is it? Okay. Instead of sending it the frame, I'm just gonna not send it anything. So we get a camera frame. We don't need to return the frame. I don't think we do return the frame. So then we send the images to OpenAI. There we go. Instead of this, we just take it and we get rid of that entirely. We don't pass in images. We only pass in prompt. Then we move everything over. And it's like for image in last few frames. Image. Okay. Let's see if that materially changes things. Oh, and then we can actually take a camera frame. We can tell it to get a frame. Yeah, get camera frame. After it's done with every action. So then during the act phase, we can take a snippet of like what just happened. Yeah, there we go. Get camera frame. Okay. Now let's try that. That'll give it a little snapshot. Oh no, video capture died. No. Wait, okay. Video capture died. Okay, wait. Hold on. Just did a bunch of things. Output? No, terminal. There we go. 1 second. Where were we? Okay. Oh, was there like a cat? Can it see things? Okay. Image 1. Fluffy tabby cat. Tabby cat stood. Cat is leaping. What? Those are hallucinations. Okay.
I mean, the bag of food has a cat, but my cat is upstairs.
Yeah, I don't think it's leaping towards the mouse toy. It's like, it definitely hallucinated those images. So, okay, wait, hold on. So, all right. Unable to open stream. Return. We initialize video capture. We try to take the frame. We remove it. We read, it says unable to fetch frame. Encode image frame. Okay, wait. In here, what we did before was get. Okay, wait. Let's act. Run. Send images to OpenAI. Okay. Last few frames. Okay. Yeah, it should be able to. Hold on, wait. Rover.jpg. Get camera frame. Come on, wait. Okay, so hold on. I think up here, yeah. We get the frame, then we insert it as JPEG. Okay. Read the image file. With open 64 images code image file. Yeah, okay. Let's try again. Let's see. Okay, it says video capture died. What? Oh, expected stir. Hold on, wait. Not path-like object. Or OS path-like object, not buffered reader. Okay, hold on. So then, rather than that's a read buffer. Path-like object. Maybe that will work. Yeah. Okay. One more time. Where's the terminal? There we go. Okay. One more time. Okay, it didn't say it died. It captured the frame. Oh, looks like it's working. We'll see. Alright, it's facing the wall. Sees a stool. Turn right. Wait, yeah. Cat tree. Facing a wall. I should turn right. So then it turned right. It did seem like it got its right and left a little bit confused there, so okay, capture frame. So it captures frames in between. So it should, okay. Observations. All right. All right, now we're here in the bathroom. I'm gonna explore. There we go. So now it's able to see the last few images, right, all at once. But yeah. All right, we're starting to dwindle. Starting to get down to the last 8 minutes of our typical stream. Looks like it is. I don't know what that was there, but yeah, let's see what we got. What's this looking like? Okay, so it takes a frame every time it does an action, so that the AI can see the results of each action without having to redetermine what it wants to do, right? So it can now kind of see like what happened to its, like, you know, each movement, right? I think this will be interesting because if we want to train it to be able to navigate a 3D space, it needs to be able to sort of map that 3D space. And so we need to know like what movement corresponded with which image, right? So, I mean, yeah, just capturing a frame every single time and just leaving those there, and so that later we can actually train what's known as a large action model or a language action model. That is kind of the goal. So right now it's really just running in Joaquin's spot, just hanging out, chilling, doing cool stuff. But yeah.
I think we really need to compensate for the lag in order to have that thing working.
Yeah.
Probably I'll have to work on a new type of video server.
Yeah. Yeah. It's possible. Is it just the network, really?
Now, there's a configuration in my server that I haven't been able to change.
Oh, yeah. Yeah, we could get on after this and see if we can debug the lag. Yeah. But yeah. Yeah, I mean, I have hard-coded, like, wait times, so, you know, it's doing okay. Yeah, backed up 5 seconds. Interesting. It's just so interesting to watch it, like, wander around and, like, decide what it's doing and execute little scripts to move around. Like, that part is very cool to me, executing of little scripts to move around. I'm pretty thrilled about that. I feel like it's gotten better at movement too, and also about navigating the space. And I feel like because of the 5 images, it's got a little bit better like recent memory, you know? So, yeah.
Yeah, it's moving way better than last time.
Yeah. Yeah. Gamers trying to call me. That's cool. So we know we're doing good. Cool. Well, yeah, I'm pretty satisfied with like how far we got. I feel like my brain is a little tired to like do that third thing that, you know, but I'll get there. I also want to think better about the self-modifying rover. Like, there's a lot of ways we can handle that, but the structure of it will matter a lot, and so I want it to, I don't know, just work a little better. So, yeah, and I want to think about the structure, but haven't had the chance. So, but yeah, I'm excited about. We're gonna go work on cars and stuff soon, so that'll be cool.
Yeah, that's gonna be great.
Yeah.
I don't know if we can tell them yet.
I won't say anything, but it'll be cool. I'm excited. So. All right. Well, I'm gonna hang out for 5 more minutes, or like 3 more minutes. If anybody's got questions they've been dying to ask, I'm here. I'll answer them. Perplexity, I have heard of. It's pretty great. I do like it quite a lot, so I do recommend it. Perplexity is pretty good. I think it's a search mostly. So there's like a pro search. It's like better search, but consensus AI or .app or something like that. Yeah, consensus. This one is really great because it's focused mostly on the science research. Perplexity hits the whole web, and so you can find stuff like, I mean, there's reverse image search and that kind of stuff, but I really like consensus. It searches all the research, and they've already like downloaded it, digested it, added tags and things like that. So if you're building an agent and you want it to be able to use science, consensus, it's pretty cool. But yeah, let's see. What else we got? Anybody else got questions? Nope. No, something wrong with it. Emitting? I don't know. Yeah. Okay, cool. How often do I stream? Right now, I'm only really streaming on Fridays. I do run classes, but those are like in person, or not in person, but they're like, you know, they're paid classes on the website. I'm usually here on Fridays. So yeah, that's the current jam. So yeah. What else? Anybody else got questions? computer science professor? Help you out? Teach you about things? I don't know. If not, it's okay. Just watch the rover go. It's fascinating. It's got a little decision-making process that you can read, you know. So, yeah. 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 Every Friday. Yeah, check it out. We do stuff. Teach you to use AI if you're interested in making your own self-modifying stuff. Like, I mean, you know, it's still work. It's still code. You still got to write stuff. And if you're not a coder yet, it's okay if you're cool with asking ChatGPT a lot of questions about code, or like trying to write code with ChatGPT. That stuff, it really does work. You produce code that works. You're gonna produce some code that has some errors in it, and you fix the errors. ChatGPT will help you. And if you just kind of believe in the concept that like I will eventually get it to work, if you're there, then you can participate without knowing necessarily how to code. But if you're gonna get overwhelmed by new things and it's like I'm really not that great with computers yet, like the first 2 classes will teach you how to use AIs, but the rest are a little bit more advanced. You do kind of need to know how to code to be able to write like a self-modifying AI, you know. So, but yeah, if you can do that, then you're good to go. Yeah. All right, y'all. It was really fun. This was great. I would say there's not a certificate yet. It just doesn't. There's not any standards. We haven't fully figured this technology out. We don't know what the edges are. We just invented automatic design of agentic systems like in the last 12 months. It's not a solid field yet. There's a lot of exploration space. So certificate's hard. Really, you have projects and experience, and no one has experience. And so it's like, you're like, I built this thing, and no one can argue with you that you didn't build the thing. So I think we're gonna eventually do a certificate, but it's like it's a lot to come up with like a test and standards and like be able to evaluate it and that kind of stuff. So certificates are tricky, and they're kind of at the end. Like there's not even a certificate for web development that really makes sense that like everyone believes in, because we still haven't solidified web development. So I have a feeling that a certificate for AI stuff is going to be hard to really put forward because it's going to move too fast. Anyway, let me know if you need anything, and thanks for coming. I hope you had a good time, everyone. I'll see you soon. Bye.
Bye.
Bye.